Okay, so we're still working on chain rule, and now we have this next section, 2.4c, where we're just going to continue kind of practicing our skills. And here's our first problem. We have a function tangent radical x, and what I want to do is I want to find f prime of x, the derivative. So totally a composite function. We see that there's an inside-outside portion that we can study here. The inside of this function is the radical x, and the outside is the tangent. So that's kind of what we're studying. So what I'm going to do is I'm going to do the derivative of the inside, this radical x, and to derive it, I'm going to use the radical rule that we learned yesterday. So derivative of the inside, so the derivative of x is 1 over 2 times itself. 1 over 2 radical x, and that is the derivative of this entire thing. So we've got the derivative of the inside. Now we're going to times it by the derivative of the outside. So tangent, what's the derivative of tangent? It's secant squared. So we have secant squared. And then the rule says keeping the inside, so keeping the radical x on the inside. And this essentially is going to be our answer to the derivative of tangent of radical x. And we can leave it like that, or we could clean it up a little bit, but I'm going to let it stay just like that. So I have one for you guys to try. Derive this thing. H of x equals the sine of 5 over x. Go ahead and pause the video and derive that and see if you can do it right. Alright, so first off, I think the smart step would have been to look at 5 over x here and probably decide you want to rewrite it. So I'm going to change it. I'm going to write h of x equals sine, and then instead of 5 over x, I'm going to do 5x to the negative 1 power. Then we'll go ahead and we'll derive this thing. So h prime of x equals the derivative of the inside. So the derivative of the inside, I'm going to power roll. It would be negative 5x to the negative 2 power. Times the derivative of the outside, so sine derives to cosine, keeping the inside 5x to the negative 1 power, keeping that in there. And then that's pretty much my answer. I need to rewrite it. It doesn't look very good, so I'm going to write h prime of x equals, we don't like these negative powers, so negative 5x to the negative 2, I'm going to make that negative 5. And then I'm going to write cosine of 5x to the negative 1. Why don't we write 5 over x? And then all over, and we're going to put this x to the negative 2, this thing, we're going to move it down. So it's going to be at the bottom, x squared, down at the bottom. And then this is the right answer. So hopefully you got the right answer. You can check yours and kind of compare it to mine. Alright, so one more here. Let's do this. Let's say you had a double chain rule problem, our favorite. So this double chain rule is going to be y equals, and we're going to do secant cubed of x squared. I want to derive this. Pause the video and try it. See if you can figure out what secant cubed of x squared would be. Your first step, if you're done working on this, would have been to rewrite it. So I would have rewritten this whole thing and said, you know what, let's erase that cubed, and instead think of it as like an entire secant of x squared cubed, like this. That way I can see that there's a little inside and then this big inside that we're kind of studying. So I see the two pieces, the little inside and the big inside. So when I go to derive it, I'm going to be finding dy dx, or y prime, and we're going to do the derivative of the little inside first. So the x squared, I'm going to tackle that first. So the derivative of x squared is 2x times the derivative of the outside, so secant, the derivative of secant is secant of something times tangent of something. And the rule says keeping the inside, so when I write secant of, I'm going to do secant of x squared. So x squared, I barely left myself any space here. Secant of x squared, let's rewrite this so I have some room. So secant of x squared, tangent of x squared. And that's the derivative of all of this whole entire inside. So I've chain ruled it. Derivative of the inside is 2x times secant tangent, keeping the inside. Well, now I got to times it one more time by the derivative of this whole entire outside piece, which is something to the third power. So if I bring down the third power, I'm going to have something to the second power. And the rule is keeping the inside, so keeping secant of x squared. And this is my answer, but I'm going to rewrite it. I'm going to write 2x times 3 is 6x. Secant tangent times secant squared is secant cubed of x squared times tangent of x squared. And that'll be my answer. So dy dx equals all of this. And if you got this right, then you're getting this double chain rule stuff down. You're doing fine. So there's your answer. So let's apply this to something today besides just practicing the chain rule over and over again. Let's look at an application. So here's our last example. We've got a story or a situation here. And you might want to write this down. You can pause the video if I go fast. The position of a moving object along a line is given in meters by P of t equals, so here's our equation, P of t equals t squared times the sine of pi t for t greater than or equal to 0 seconds. Our question is, find the object's velocity when time equals a half a second. Find the object's velocity when time equals half a second. So we have the position of some moving object given by this function, and we want to find velocity at time equals a half a second, which is a moment in time. So this is definitely an instantaneous rate of change. I can tell it's an instant, which means I need a derivative. I need to find velocity, and if p of t is my function, then I need p prime. So what I'm going to do is I'm going to make some space to show my work here. I'm going to copy the function P of t equals t squared times the sine of pi t, times the sine of pi t. And let's just start off by deriving this and kind of going through the process of how we would solve this. So first off, I need to find p prime. And I'm going to be applying a couple of things. I have t squared times the sine of pi t. So I'm going to be applying the product rule. I have a first and a second. So I have the first t squared times the derivative of the second, sine pi t. Now pi t is just a number. It's 3.14 times t. So we're going to do chain rule. We're going to do derivative of the inside. Pi t, if I derived it, would just be pi. Times the derivative of the outside, sine derives to cosine. Keeping the inside, pi t. So that's my first times the derivative of the second. Now I'm going to do plus the second. So sine pi t is my second, times the derivative of my first. T squared is going to be 2t when I power roll it. And then I'm ready to figure out my next step. Next step is I want to know what is p prime, the velocity, at a half a second. So we're going to plug in 1/2 and get an answer, which means everywhere there's a t becomes a 1/2. So we're going to have 1/2 squared instead of t squared, times pi times cosine of pi times a half plus sine of pi times a half times 2t, so times 2 times a half. And basically I just have a little bit of math to kind of clean up here. So 1/2 squared, this first piece here, 1/2 squared is 1/4. And we've got this pi here, so why don't I say pi over 4, pi fourth, times the cosine of pi times a half, so that'd be pi over 2. Plus sine of pi times a half, so that'd be sine of pi over 2. Times 2 times a half down here. Well, 2 times a half, we know that cancels to times 1, which is going to go away altogether. So now it comes down to knowing your unit circle, knowing that on the unit circle, when we're talking about pi over 2, that we're talking about the top of the unit circle. So what is cosine at pi over 2? That's the kind of thing you want to be answering. So cosine at pi over 2 is going to be 0. So we're going to have, this whole thing is pi over 4 times 0, plus the sine at pi over 2, well, sine up here at the top of the unit circle is going to be 1. So we have pi over 4 times 0 plus 1. So the entire answer is going to equal, down at the bottom here, 1. So p prime of 1/2 equals 1. There is my answer. And if you go back and you kind of check the question out that said find the object's velocity when time equals 1/2 second, well, now we know its velocity is 1 and the units were meters and seconds. So what I'm going to do is I'm going to write p prime of 1/2 equals 1 meter per second, which means the object that is moving has a positive velocity, and if velocity is positive, then we know the object's going to the right. So the object moves to the right. And there is my answer. Object moves to the right. Okay, so just a little idea of how to do some of this chain rule stuff. So here's what I want you to do. Keep practicing and working on this, and the more you practice, the better and better you'll get at this.